Hello everyone, this is INE Foundation Lab 3 and section 4.2 Type Version 2 continued. Okay, this section is about BFT technology. Let's see BFT concept and I will come back and configure this section. Okay, BFT stands bidirectional forward detection. BFT is a detection protocol designed to provide fast forwarding path failure detection times for all media types, encapsulation, topologies, and routing protocols. BFT is a protocol that provides sub-second failure detection. You can configure BFT at the interface or in routing protocol levels. You can configure BFT in two levels. One is interface and the other one is routing protocol levels. We use interface level for BFT timers. This is how we can configure BFT timers. I will explain this a little bit later. Cisco support the BFT asynchronous mode, which depends on the sending of BFT control packets between two systems. It means BFT must be configured on both systems. If we have it should be configured between two routers. Okay, as I explained before, BFT can be configured on the interface level and routing protocol levels. To configure BFT in interface level, we simply go on the interface configuration mode and type BFT interval and specify millisecond and type min_rx, then milliseconds, and multiplier and specify interval multiplier. This is how we can configure BFT timers. BFT routing protocol level configuration. Let's check how we can configure BFT for BGP. On the BGP configuration mode, we type neighbor remote IP addresses and type file dash over BFT. This is how we can configure BFT for BGP by neighbor remote IP and file dash over BFT command. To verify our BFT configuration for BGP, we use show BFT neighbors, show BFT neighbor details, or show IPBGP neighbors. The show BFT neighbor details is we can use this command for all routing protocols: OSPF, PIG, IPBGP, and RIP. For configure BFT for EIGRP, we can configure in two ways. BFT can be enabled for all of the interfaces. We can use BFT-interface command under router EIGRP configuration mode, and we can also enable for subset of interfaces by this command. BFT under EIGRP configuration, we type BFT interface and type our interface that BFT should be enabled. For verifying our BFT, we type show BFT neighbor details. This is for all routing protocols, and show IPIGRP interface and type AS number and details. ISIS. ISIS and OSPF is similar to each other. BFT works in the same ways. We can configure BFT. It can be enabled for all of the interfaces. Then we can disable for one or more interfaces on the ISIS. On the router ISIS configuration mode, we type BFT all interface command display enable BFT for all interfaces. Then type interface and type ISI BFT disable command. We can disable BFT on the interface level configuration for ISIS by this command, ISIS BFT disable command. And for verifying our BFT, we have show BFT enable and show CLNS interface. We can configure BFT on the interface level for our interface. We want to enter by this command. On the interface level configuration, we type ISIS BFT, display enable BFT for our interface. Okay, OSPF is similar to ISIS. BFT can be enabled for all interfaces, then it can be disabled for one or more interfaces. Under OSPF process ID, under OSPF configuration mode, we type BFT all interfaces. Then for disable BFT for our interface, we type under interface configuration mode we type IPOSPF BFT disable. And this, we can verify about these two commands, show BFT enables and show IPOSPF. We can enable BFT for one or more interfaces by this command. On the interface level configuration, we type IPOSPF BFT command. If we type disable, it will disable BFT for our interface. Without disable, it will enable it. And we can verify about these two commands, so IPOSPF and show BFT enable details. We can configure BFT for HSRP either. Can be enabled on interface. On the interface level configuration mode, we type standby BFT command. We can also enable BFT globally for all interfaces in HSRP. Simply under router configuration mode, we type standby BFT all -interface command. And for RIP, okay, BFT for RIP is different, is working differently than other routing protocols. BFT is independent of RIP version 2 and must be enabled and functional on the router. RIP uses the timeout prefix of particular neighbor to identify if neighbor is inactive. This is RIP using timeout prefix for identify if our neighbor is inactive or active, and the default timeout is 180 seconds, which means that even if the next supporter is inactive, the RIP timer will still broadcast prefix for up to 180 seconds. This is timeout. Our timeout is working. If the default timeout is 180, and RIP will broadcast prefix up to this 180 if the route is inactive. Okay, BFT for RIP invalidates the route from the RIP or routing information base as soon as the BFT adjacency is lost. If we don't receive any adjacency, RIP will invalidate that route from RIP. And the RIP routes installed in the RIP via RIP neighbor are seen as inaccessible after BFT is lost the link. Okay, if the link between two routers is lost during this time, the route installed in RIP in RIP will seen as inaccessible. I will show this in the lab, but during this time the root will stay as inaccessible. Okay, we can configure BFT for RIP in two ways. One way is we can enable for all interfaces on the router RIP configuration mode with our BFT all interface command. We can configure BFT for neighbor routers under router RIP with our neighbor IP remote IP address and specified BFT and our BFT all interfaces. This will enable BFT for all interfaces for our RIP neighbor. Okay, that's it. This is how BFT is working, and how we can configure BFT for all type of routing protocols. For RIP, it is working in different way. Okay, now let's configure this section. Okay, one thing I want to mention is that we for RIP we can configure BFT timers on the interface level configuration and enable BFT for our routers by these two ways. Okay, let's configure. This is topology. We have RIP version 2 between R9 and R1. Okay, configure RIP version 2 to mark routes as inaccessible 750 MSECs after detecting a link failure between R1 and R9. We have to configure RIP version 2 to mark routes as inaccessible after the link is failed. Okay, let's see our configuration for the show IP route RIP. Okay, this is our RIP protocol. Yeah, I have configured RIP in previous section. Okay, but we show IP route 1111. This is 9 via RIP, and distance is 1. This is metric, and last update from this one. But show IP route 9999. 9 via RIP, and metric is 15 this time. If I showdown pipe section router RIP, this is why, because I have configured offset this by with metric of 14 plus 1 is 15. Okay, let's configure BFT. Let's configure BFT timers on the interface. Config T. It should be this interface. Interface this one. On type BFT interval. Okay, it should be 750. And 50 divide into 3. 240. 40. Then min x 240 and multiply is 3. As simply is on the config T interface this one. and type this command. And now let's enable BFT. On the reporter RIP. And type BFT all interfaces. Okay, that's it. Let's verify. Show BFT neighbor details. It says register protocol is RIP SEP. This is BFT is available for our RIP. And this minimum echo interval and multiply is 3. And so okay, now let's debug RIP BFT events. And let's disable this interface config T. This should be this interface. And I type shutdown. And let's check show IP route 1111. Now it says non via RIP. This transmitting and this is inaccessible. This is how this is BFT for invalidated route via RIP. As soon as the BFT address is lost, I have shut down this device. It will invalidate the route, and the route installed in RIP via the RIP neighbor are seen as inaccessible. After BFT lost the link, we can verify this here. Type, and if I wait a little more, I'm gone. The route is gone. BFT session and destroyed. Pass it along. Okay, that's it. This is how BFT is working for RIP, and I hope you have enjoyed this video, and thank you for viewing.